Welcome back to Networking Explained, Episode 12. Today we're tackling a concept that quietly powers half the modern web, webhooks. The core idea is simple. Instead of your app constantly asking another service, anything new yet? How about now? The service just tells you the moment something happens. Don't poll, get notified. So picture this. Your app needs to know the instant a payment goes through. The old approach? Ask the payment provider every few seconds, thousands of times an hour, and almost every answer is nope, not yet. You're burning bandwidth, hammering their servers, and you still find out late. But flip it around. What if the provider just called you the moment the payment cleared? That callback, that little knock on your door, is a webhook. So let's nail down the definition in one clean sentence. A webhook is an automated HTTP call. One app fires off to another the very moment something happens. Think of it as a reverse API. Instead of you reaching out and asking, the other service pushes the news straight to a URL you own. Three things to lock in. It's triggered by an event, it lands as a post on your endpoint, and it's push, not pull. Here's the mental model I want to stick in your head. You order a pizza. Polling is calling the shop every 2 minutes, asking if it's ready. Annoying for them, exhausting for you, and you'll probably still miss the perfect moment. A webhook is leaving your number and letting them text you the second it comes out of the oven. Same outcome, completely different effort. Phoning repeatedly maps to polling an API. Leaving your number is registering a webhook. The "it's ready" text is the event firing, and the pizza itself, that's the payload you actually care about. Now let's put them side by side. With polling, your app keeps knocking on the provider's door. Any news? Any news? Any news? Until finally, one of those calls gets a yes. Every other request was wasted bandwidth, wasted CPU, wasted money. With a webhook, you register your URL once and then you go quiet. When the event actually happens, the provider calls you back exactly once. No noise, no waste, just the signal you were waiting for. Script. So let's trace that lifecycle end to end. First, just once, you tell the provider where to reach you. That's your endpoint URL. After that, you wait. When something interesting happens on their side, a payment clears, a commit lands, a message arrives, they fire off an HTTP post to your URL with the event data attached. Your server reads it, does whatever it needs to do, and replies with a 200 OK to say, got it, thanks. Step 1 happens once. Steps 2 through 4 repeat forever, for every event. And notice there's not a single poll in sight. Estimated seconds. So what does one of these actually look like on the wire? It's just a plain HTTP post. Here, Stripe is hitting your endpoint with a JSON body describing what happened. A payment succeeded, $42, US currency, nothing magical. The one line worth paying attention to is that Stripe signature header. That's how you confirm the request really came from Stripe and not someone who guessed your URL. We'll come back to verifying that in a bit. Now let's nail down the core distinction, because this trips people up. With a normal API call, you're the one initiating. You reach out and ask, hey, what's the status? It's a pull on your schedule. A webhook flips that completely. The provider initiates reaching out to you the moment something happens. It's a push on their schedule. Same HTTP under the hood, just opposite directions. And once you start looking, you'll spot webhooks everywhere. Stripe pings your server the instant a payment goes through. GitHub fires off your CI pipeline the moment someone pushes code. Slack and Discord forward new messages to your bot, and your shipping provider lets your app know the second a package goes out. Pretty much every modern SaaS offers them. It's how services quietly react to each other in real time. But here's the catch. Your webhook URL sits out on the open internet, and anyone who finds it could post a fake payment succeeded event straight to your server. That's why providers sign every request with a shared secret. You recompute that signature on your end and reject anything that doesn't match. Always stick to HTTPS so the payload stays encrypted in transit. And when in doubt, refetch the event through the API to confirm it's real. Rule of thumb, never trust an unverified webhook. Now, once you've verified the event is genuine, there's another reality to deal with. Providers don't just send each event once. If your server is down, slow, or replies with anything other than a 200, they'll keep retrying, often for hours with exponential backoff. That's great for reliability, but it means the same event can land twice. The fix: be idempotent. Process each event by its unique ID, so a duplicate just becomes a no-op. Same event in, same result out. So let's pull all of this together into a quick cheat sheet. On the do side, verify every signature, reply with a 200 as fast as you can, process events idempotently, and push the heavy lifting onto a queue. On the avoid side, don't trust raw payloads, don't block the response on slow work, don't assume exactly once delivery, and don't try to do everything inline. Follow that pattern, and your webhook endpoint stays fast, safe, and boringly reliable, which is exactly what you want. Now that we know the rules, let's clear up a few myths that trip people up. First, webhooks aren't some special protocol. It's just a plain HTTP post to a URL you gave out, nothing exotic. Second, don't assume exactly once delivery. Most providers are at least once, so retries will create duplicates, which is exactly why your handler needs to be idempotent. And third, just because a request landed on your endpoint doesn't mean it's genuine. Anyone can post to a public URL, so always verify that signature before you trust a single byte. With the myths out of the way, let's place webhooks next to their two closest cousins. Webhooks are one-way, server to server, firing a single HTTP call when something happens. Perfect for backend events like payments or deploys. WebSockets keep a persistent two-way pipe open, which is what you want for live chat or collaborative UIs. And polling is the client repeatedly asking, anything new yet? Fine for simple, infrequent checks, but wasteful once things get busy. Now that the concepts are clear, let's look at the tools you'll actually bump into. Stripe sends payment events, GitHub fires on pushes, pull requests, and issues, and Slack and Discord use webhooks for bots and messages. On the developer side, Zapier and Make let you wire things up without code. Grok exposes your local host so you can test real deliveries. And platforms like Svix or HookDeck handle the heavy infrastructure, retries, signing, dashboards, so you don't have to build it yourself. So let's pull it all together. A webhook is just an HTTP post fired the moment something happens. Push, not pull, a kind of reverse API where you hand over a URL and they call you with the data. Two things to burn into memory. Always verify the signature because that URL is sitting out on the public internet, and always design your handler to be idempotent because retries and duplicates are a question of when, not if. So, how do you actually choose in the moment? Here's the quick decision tree. If you need to know the instant something happens, that's a webhook, no debate. If the other service already offers them, just use what's there, don't reinvent it. If there's genuinely no webhook available, then yes, poll, but sparingly with sensible intervals. And for a one-off, on-demand check, skip the ceremony and just call the API directly. If you want to keep building on this, the Networking Explained series goes deeper into the surrounding pieces: HTTP and REST, API gateways, WebSocket, WebRTC, and of course, more on webhooks themselves. And one thing worth repeating before you ship: a public webhook URL is an attack surface, so signature verification, HTTPS, and rate limiting aren't optional. They're the baseline for doing this safely. So before we wrap, a quick question for you. Is there something in your stack right now that's still being polled when it really could be a webhook? We've all been guilty of leaving a cron job out there hammering an endpoint every minute. If you've made that switch, I'd love to hear what you moved over. And be honest, did you remember to verify those signatures? Drop it in the comments. And that's webhooks. Hopefully, the mental model finally clicked. If it did, hit subscribe and stick around for the rest of the Networking Explained series, where we'll keep breaking down the pieces that make modern backends actually work. You can also find more deep dives over at dargslan.com. Thanks for hanging out with me. And remember, don't poll, get notified. See you in the next one.